Okay, Assalamualaikum and hello. So we continue with our next study, okay, which is transmission line. Okay. So previously we learned about generation, power generation. Okay, now we move on to the next part. After we generate, we have to transmit the energy. Okay. So try to look at the notes. Okay, notes provided you can see here. This is the next part, transmission. Okay, so let me make this bigger. Okay, so part 2, transmission 9. Okay, at the end of this topic you should able to list and describe various type of transmission line, also discuss the basic concept related to the design and structure of the transmission line, then identify the transmission line parameter, and then you have to learn you have to know about the model of line into suitable line representative, and then analyze the power flow and performance of the line in terms of efficiency and voltage regulation. So this one is the calculation part. Okay, so this topic mostly focus on the theory. Okay, so let's start with the transmission line. Is a component in the power system which connect the generation station to the distribution section of the customer. So what is this mean is, okay, what is this mean is, okay, you have a generation here, okay, and you have a customer here. Okay, a customer is basically load. Okay, you have various type of load. So how to do this? So basically we have a distribution system, of course, to distribute the energy to the various customer. And then, so what is this mean? Transmission line is that you have a transmission line to do the before you can distribute it. Okay, so if you look at outside, you can see a big tower. Okay, something like this. Okay, big tower, and you have a wire here. Okay, this one also. Okay, so this is the transmission line. Okay, let me Google it for you if you never see a transmission line. Okay, this is the example of transmission line. Okay, all of these are transmission line. So basically this is air insulated, means that there is, this one is a bare wire, there is no insulation. Okay, if you touch this, okay, it is quite dangerous. Okay, but if you touch this, nothing happen because the potential is the same. But if you touch this and touch the ground, that one is quite dangerous. Okay, so example here. Okay, no need to worry. This one. Okay, I think most of you see this one. Okay, this one is Malaysian type of grid transmission line. Okay, so let's move on to the next part. Okay, so this is what it means by transmission line. And then to reduce the power loss in a long distance transmission line operates at a very high voltage. Okay, so this one I already mentioned before. Okay, so in the transformer, remember, if you recall back, for example, you have a generation. Okay, and then you have 11 kV, 10 kV, easy. Okay, easy to calculate, but it's not a standard one, usually around 11, I think, if not mistaken. So you have a transformer, and then you increase it to, for example, 100 kV. So if you, for example, here 10 kV, and 10 kV is 100 ampere. For example, this one is 10 kV, 100 ampere. If you increase the voltage here, the current will become 10 ampere. So because what? P in is equals to P out for transformer. So this is ideal condition, but it's not perfect. Remember, transformer is around 90% efficiency or higher. Okay, so to make it easy, is P1 is actually around is same as P out. P in is equals to P out. So if you can see here, the current is actually reduced from 100 ampere to 10 ampere. So why? P loss is equals to I squared R. So R is the resistance of wire. Okay, it's very small, but it can be affected if the current is very high. Okay, and you can see here this is square. The higher the current, the higher the power loss in the form of exponential. So if I plot this, this is P. Okay, the power loss become like this. Okay, the higher the current, the higher the power loss. That's why we have to reduce the current. To do that, we have to increase the voltage. That's why in transmission line the voltage is very high. Okay, for Malaysian, okay, you have three standard. Okay, different country have different standard, but in Malaysia you have 132, 275 and 500 kilovolt. Okay, make sure you know this. This is the standard transmission line voltage. Okay, so most long distance line are overhead line due to the cost and technical consideration. So remember that I said in the transmission line is usually overhead, so something like this. So I said that there is no insulation. Okay, why? Because for long distance is actually very more cost effective if you use the air insulation. Okay, basically it is more cost effective. Okay, however, there exists underground line or submarine cable used to transmit power across congested area and river and or sea. So okay, mostly we use this one, but sometimes we can also use underground wire. Okay, so underground wire, the advantage of it, okay, you can even though the cost is quite high, but you don't have to see this. Okay, some people don't like this. Okay, but if they use underground, it is much more costly, but you don't have to see this. Okay, and another thing you need to know, the higher the voltage, the larger the tower. You can see here. Okay, larger voltage, larger tower. Okay, so some of the country try to avoid using the tower, but cannot avoid using the tower, but it can be something like this in the form of art. Okay, sometimes they do some the transmission power in the form of this is just an extra information. Okay, there will be no unique transmission line in the exam. Okay, so we move on to the next part. Conductor for transmission line in general are made of aluminium or copper. Copper has better conductivity per unit volume compared to aluminium, but it is more costly and worse conductivity per unit weight. So you can be either conductor and be aluminium or copper. Okay, but copper has better conductivity per volume. Okay, but it is much more costly. Okay, remember copper is much more costly than aluminium per weight. Okay, has worse conductivity per weight. So worse conductivity per weight. Okay, it's better conductivity per volume, but not better conductivity per weight. So basically it is heavy. Okay, much more heavy compared to aluminium. Okay, so the most common one is aluminium. okay, because it is cheaper and better conductivity per weight. Okay, so make sure you know the conductors of the transmission line. Okay, and what it means by conductivity, remember P loss equals to I squared R. Okay, this is the conductivity. Okay, the resistance here. Okay, so the resistance will go into this one. So basically, if you use copper, it has lower R, so you can use a lot more current. Okay, but the problem is the cost. Copper is quite expensive. Okay, so next, there are 4 types of aluminium conductor typically used. Okay, so this one is all aluminium conductor, AAC. Okay, basically all of it are aluminium. And then you have all aluminium alloy conductor, so this is mixed. Okay, AAC, all aluminium alloy conductor. And then you have aluminium conductor steel reinforced, ACSR. And lastly, aluminium conductor alloy reinforced, ACAR. Okay, so aluminium conductor support by the alloy are more common because it's the combination of the material increase the conductor strength. Okay, so if you know alloy is just basically combination of metal. Okay, and it is much more commonly used in the transmission line. So make sure you know what is AAC, AAC, ACSR, and ACAR. Okay, this is what it means by the steel reinforcement. Okay, you have 7 conductors in the arrangement in the form of core strength, and the steel conductor are surrounding by the 24 aluminium conductor. Okay, so you can see here the cross section view. Okay, you have 7 here is the steel conductor. Okay, and surrounded is the aluminium conductor. So this arrangement is stated simply as the 24 aluminium, 7 steel, or 24/7. So this one is basically, remember here, to increase the conductor's strength. Okay, basically you want to make it higher strength. Okay, make it much more durable. Okay, so this is the arrangement of ACSR. Okay, 24 AI 7 ST. Okay, next, conductor used for high voltage overhead transmission line are bare. Okay, this one I already explained. It doesn't have any insulation. It's just a bare wire. Okay, uncovered. Okay, why we want to do this? Because we want to ease the heat dissipation to the surrounding and reduce the weight. Okay, so if you look back, if you look here, okay, if you look here, let me show you. Okay, you can see here this is bare wire. Okay, usually we can see that the wire has insulation, right, normally, but for transmission line it doesn't have any insulation. Okay, this is the wire. Okay, basically why? Because we want to ease the heat dissipation. Okay, remember P loss equals to I squared R. The power loss is in the form of heat. Okay, and ease the dissipation. Okay, so also insulation is quite heavy, so you want to reduce the weight. Okay, the line is insulated by the pin insulator that are suspended in the transmission line tower and by the air surrounding the conductor. So okay, maybe this one is easier. So this is basically the insulator. Okay, this one cannot touch the tower. Tower is the metal. Okay, metal is earth. Okay, this metal is earth. So basically, if this line, transmission line, touches the tower here, okay, it will short to the earth, short circuit. Okay, that's why it has insulator here. Basically, between tower and the transmission line, you have the okay, insulator, and between the other parts is the air. Okay, the air is the insulator. Okay, and the pin insulator are commonly made by the porcelain or glass, or also support the conductor tower. Okay, so it made of the porcelain or glass, okay, because it is insulator. Underground conductor should be well insulated and protected against external element. So this one for underground also need insulation. Okay, so underground it's usually insulation. Okay, you need a different type of insulation. For overhead, you use bare wired, because we can use the air as insulator and use the insulator here, okay, as the insulator. Okay, this is the conductor for overhead line. Okay, you can see here, overhead line is a bare wire. Okay, this is bare wire, and this one underground line. You can see here, there is a lot of insulation and the metal here to protect the cable. Okay, so that's why it is much more costly. Okay, because you have a lot of material here, but for bare wire is much more cheaper. Okay, so overhead line mostly transmit by overhead line. Okay, this one already explained. The conductor are not insulated except by the pin insulator and the transmission at the transmission tower. Also already explained. The pin insulator, this one is not very clear. Okay, it's good. Okay, this one is the underground lines. Okay, underground lines are used to transmit across river or sea or through densely populated area. So if you have a high building, okay, if you have a high building at the populated area, or you have a sea here, so overhead line is not suitable. Okay, because if the tree or building get close to here, it can short circuit, because it is also has potential at the earth. Okay, if building or something, so it can short circuit and people can get electrocuted. Okay, that's why we use underground line. Okay, underground line are not suitable for the high power application, because the heat is not easy dissipate from the line. Okay, so remember, this is usually has many insulator, and also it is underground, so the heat cannot dissipate easily. Okay, next is the high voltage alternating current line, HVAC. Okay, HVAC line use three-phase conductor arrangement to transmit power at high voltage distribution section. Relatively low AC voltage at the generation are increased by step-up transformer at the transmission line. So this one I already explained here. Okay. Okay, where is it? This one. Okay. So HVAC, this one, high voltage AC. So basically you have a low voltage here and increase the voltage using step-up transformer. And also I already explained, in Malaysia you have 132 kV, 275 kV and 500 kV. This is the standard for Malaysia. Okay, next is the high voltage direct current line. So previously is high voltage AC, now high voltage DC. Okay, so you have two types, either AC or DC. HVDC are typically used in two situations. Okay, one is to transmit power at an extremely long distance. Okay, so for very long distance, okay, if a normal distance, okay, usually we have to use AC, but if it is very long, it is not suitable because of the cost. Okay, and to connect two power system with different frequency, so a synchronized system or different country. So if you have, for example, in Malaysia we use 50 Hz, okay, and for, if not mistaken, is Thailand use 60 Hz. So between Malaysia and Thailand we have a high voltage DC current line. Okay, so because we have two different frequency, we cannot just connect it you have to convert to DC first and then convert to AC back. Okay, or extremely long distance. So this is the function of the high voltage DC system. Okay, so let me check the recording first. Okay, so as I mentioned before, to transmit the power at long distance, it is more economic to use high voltage DC rather than HV AC. Okay, it's just more economic. Even though the cost to provide the DC AC conversion or inverter, okay, is in the HVDC system is high, but it can be compensated by relatively low cost of HVDC line construction and no significant magnetic or electrical field effect from the line to the environment. Okay, so maybe I should draw this. Okay, let me clear it. Okay, why? Okay, so like I mentioned before, you have different frequency here. Okay, it doesn't respond. Okay, so you have a line here. Okay, this is 50 Hertz. Okay, you have to rectify. It's called rectify. So this is AC. After you rectify it, it becomes DC. Okay, after you rectify it become DC, and then you have to inverter. Okay, NVER okay, inverter is basically DC AC. Okay, and then it become AC 60 Hertz. Okay, so this one is basically rectify. Okay, rectifier. Okay, RECTIFIER, basically from AC DC converter. Okay, maybe this one, I think in your 4th year you will learn about this. Okay, rectifier. Or if you want to make it easy, you just remember AC to DC converter, and then DC to AC converter. DC to AC converter. Okay, or if you don't want to use this, you can just put AC converter. Okay, this one is called cyclo converter, CYCLO. Okay, this one you will learn maybe in the 4th year. Okay, so basically you have 50 Hertz and then 60 Hertz, and this thing costs very high, very high. Okay, but if the system is quite long, okay, if the AC line is quite long, okay, the system, okay, this cost, the AC cost will become lower. So if a very long distance, it is much more better to use HVDC rather than HVAC. Okay, okay, that's it. You need to know about this. Okay, furthermore, the problem with the voltage regulation and reactive compensation are not the issue for HVAC. Okay, so remember, if you learn about the you learn AC. Okay, in AC you have R, you have L, you have C, right? Okay, and for DC you only have to mention R. Okay, this is what it means, reactive compensation. Okay, you have to make sure that if it is in the circuit has too much L, okay, means that Q is high, is positive. Okay, you have to make sure you have to put the C, negative Q, okay, to compensate this, and make sure the Q, the PF within 1, okay, near to 1. Okay, you have already made the assignment. So basically TNB wants you to make sure that the power factor close to unity or 1. Okay, so that that one becomes complicated. That's why in DC you don't have this L and C problem. You don't have reactive power, only a real power. So there is no compensation issue. Okay, voltage regulation is also easier. Okay, so That is the advantages of using HVDC. Okay. There are various types of overhead line transmission structure. The tower is normally constructed with concrete, steel, or timber. In Malaysia, the tower are commonly constructed with lattice steel. The construction is very strong, relatively light, and simple to erect. Okay, so what it means that, okay, this transmission line usually maybe at the in Malaysia at the forest. Okay, so it needs to have a way to install this. So that's why we use this material, because it's easy to build. Okay. Okay, and then however the design and fabrication stage are complicated and time consuming, while the base for the tower requires significant land area. Okay, so this is the limitation of overhead line. Okay, so this is the main components. Okay, suspension insulation set. Okay, this is suspension insulation set. Okay, phase conductor, this is phase A, B, C. Okay, or RYB. Okay, remember, and don't forget, okay, most of you only heard about A, B, C. Okay, actually in Malaysia we use RYB, red, yellow, blue. Red for A, yellow for B, blue is for C. Okay, spacer between conductor of the same space. Okay, and then the shield conductor, a set of 3-phase conductor wire tower, identification of the plate for the line, secure feature against unauthorized climber. Okay, so you can see the numbering here. Okay, 1, 2, okay, 3 is the spacer. This one, you have the spacer between 2 conductors of the same phase. Okay, usually we can use 2 wire. Okay, but this one is the same phase. Okay. Okay, shield conductor number 4, where is it? This one. Okay, shield conductor. If not mistaken, this one is for thunder. Okay, if the thunder strike, it doesn't strike here, it will protect this. Okay. Okay, a set of 3 conductor wire in the tower. So this one I mentioned before, A, B, C. Okay, 6. Okay, the 6th one is the plate for the line. Okay, identification plate. So basically this tell what is the voltage and everything, and of course the security again. Okay, climber. Okay. Okay, let us start with the leakage current. Okay, so conductance between conductor that are in touch with each other, or between any conductor to earth through the suspension insulator, contributes to the flow of leakage current in the transmission line. Okay, so there is some small leakage current that flow from the conductor through the in touch with each other or through earth. Okay, however, since the leakage in a normal condition is quite negligible, the leakage reactance to present the conductance is not taken into account. Okay, usually it's not taken into account. And note that the parameter R, L, C are normally given in per unit length. Okay, so for example, resistance is ohms per kilometer. So the longer the distance, the higher the resistance. Okay, this is just an example. Okay, so now the equivalent for transmission line, the equivalent circuit for transmission line. 3-phase transmission line in a balanced load condition are represented as a single phase circuit like this. Okay, if you have 3 phase, okay, we present it as a single phase. Okay, like this. Okay, you have resistance, you have inductance here. Okay, and you have capacitance. Okay. Okay, and this is, okay, remember for electrical we usually use the left side as a source and the right side as a load. This is just a standard practice. Okay, resistance and inductance are series parameter, while the capacitance is a shunt parameters in the circuit. Okay, you can see here. Okay, R and L is in series here, and Y is in parallel. So this one is basically represent the transmission line, three-phase transmission line. Not one phase, but three-phase. Okay, three-phase, combine it into a single phase. Okay, physically, all the line parameters are distributed uniformly along the line. This means that, okay, maybe I should draw this. Okay, let me pause this. Okay, basically, you have a three transmission line, red and yellow and blue. Okay, a long, very long line. Okay, so for this one, okay, we simplified it as a single phase, something like this. Okay, so for this case, actually there are resistance here. Remember, resistance per kilometer. Okay, actually they are resistant, a small resistance here, and then you have small inductance. Okay, small inductance, and then you have something like a capacitance effects. Okay, something like this. Okay, but this one is hard to calculate. Okay, you have to combine many things, right? You have to combine all the components. So to simplify the analysis, we just simplified it into something like this. Okay, that is meant by this sentence. Okay, so basically we lump everything up together to become this element. Okay, just to simplify it. So this is R, this is L, this is C. R, L. Okay. So in this section, we will describe modeling technique available to lump the line parameter based on the length of the line, which can be divided into three representations. Okay, so this line can be short line, medium line, or long line. Okay, so short, the representation can be simpler. Then you have medium line, you have a long line. Okay, long line represent will be covered in the EMT courses. Okay, for this courses, it will not be covered, so no need to worry for the long line. Only you have to focus is short and medium line. So the higher the line, actually the more complicated the model is. Okay, because you have to consider all the parameters. Okay, the parameters has a larger effect, okay, compared to the short line.